Hello students, welcome to my channel Positron. In many videos I have told you all that why the name of my channel is a positron. Positron is actually a fundamental particle. It is an anti-particle of electron, and this name sounds very good to me. That's why the name of my channel is Positron. Dear students, many videos already have posted, made over the capacitor. Today is a we are going to solve the miscellaneous problem related to the capacitor, right? First, I'm considering problem related to the adjacent plates, right? Let some plates are like this. Now, what we have to do? We have to find out the equivalent capacitance between A and B. Here are the 5 plates. 1, 2, 3, 4, 5 plates. And these 5 plates are identical, means have the equal area and equal separation between them. So each of them has these 5 plates will form the 4 capacitors 1, 2, 3, 4. Let each having the capacitance C. Write this. Dear student, these are the one of the easiest problems, right? These problems might be asked in NEET. I don't say that is going to be asked in JEE. In order to solve this problem, first what we have to do, we should give number to the plates. 1, 2, 3, 4, 5. Now, plate number 1 and 3 is associated with A, so I'm marking here. 2 and 5 is associated with B, so I'm marking here. Now, dear students, what we have to do, we have to find out the equivalent capacitance between A and B. So I'm making a point A here, point B here. A is connected with plate 1 and 3, so I'm marking here. Plate B is connected with 2 and 5, so I'm writing here. Now look here. 1 and 2 are the plate 1 and 2 are making the first capacitor. So 1 is here is a 1, so I'm connecting plate 1 with this. 2 is a here on B, so it is a first capacitor. That is formed between the plates number 1 and 2. Now 2 and 3 are making another one. So 2 is a here, 3 is a here. So 2 and 3 is making another capacitor. These two we have considered. Dear student, 3 and 4 is making another one. 3 and 4. Here is a 3 and 4 is not written. 4 is not marked here. Means 4 is not connected with either point A or B. So what we have to do? This is the 3 number of plate and this is 4. 3 and 4 is making one of the capacitor. So I'm marking here 4. And now 4 and 5 is making another capacitor. And 5 is a here. So this is a 5 and again 4. So this is between 3 and 4 is this, and between 4 and 5 is this. Now dear student, it's a very simple. These all are C, right? Now we have to find out the equivalent capacitance between A and B. You know it's nothing you have to do. C and C, equivalent will be C by 2, is a series. Now all these C and C by 2 are in parallel combination. So equivalent capacitance will C equivalent equal to C plus C by 2, that is 2C plus C by 2, that is 2 to the 4, 1 5 C by 2, right? In this way you find the equivalent capacitance. In series combination, you know 1 upon C is equal to 1 upon C1 plus 1 upon C2. Resistance and capacitance are inverse to each other in when you are solving for the equivalent capacitance. In if you are considering the capacitors in series combination, 1 upon C is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3, so on. And in parallel combination, simply you have to add the capacitors. How do you know whether a particular combination is series or parallel? In series combination, if the charge comes here, the same charge passes through these two capacitors. And in parallel, if charge Q comes here, it is divided in these three branches, right? So, if division of charge happens, then it is a parallel combination, and in series combination, charge remains same. Dear student, in series combination, charge remains same, potential is divided. In parallel combination, potential remains same, or potential difference remains same, and charge is divided. Now, let's talk about another problem. Now, I'm going to increase the number of plates. Now, again, this is some plates I have made here. We have to find out the equivalent capacitance of this combination. Again, I am repeating my words that all the capacitors are identical, means all the parallel plates are identical. The separation between them is identical. So, any combination of the plate have the capacitance C, and that is equal. Now, dear students, again, we have to find out the equivalent capacitance between A and B. The same concept I am going to apply, that again give number to these 1, 2, 3, 4, 5, 6, 7, 8 and 9. Dear student, point A is connected with 2 and 5, so I am writing here 2 and 5, and B is connected with 4 and 8, so writing here 4 and 8. Now, in order to find out the equivalent capacitance between A and B, I have taken here a point A and here is a point B. Now, let's begin our journey. Point A is connected with 2 and 5 number plate, and this is connected with 4 and 8 number of plate. Now, dear student, look here. 1 and 2 are making one of the capacitor. Here is a 2, but 1 is not looking either on A or B. So, with the 2 I am connecting a plate, and this is a giving number 1. So, this one is here between 1 and 2. 2 is here, number 2 is marked here. So, I am marking here 1. Between 1 and 2, this capacitor comes. Now, between 2 and 3. So 2 is here, but 3 is not looking. So what I am doing here, our capacitor is plate number 2 I am writing, and let here is a writing 3. So between 2 and 3 there is a capacitor. Now between 3 and 4, another, these two already we have shown here. 3 and 4 are making another one. So 3 is here, 4 is here. So this is plate number 3 and this is plate number 4, right? Now 3 is a common plate. This is sharing with this and this both, right? So 3 and 4 is connected between B. Now 4 and 5. 4 and 5. 4 is a here and 5 is a here. So between 4 and 5, another capacitor connected. This. Now between 5 and 6, 5 is here, but 6 is not looking. 5 is here, 6 is not looking, so I'm marking here 6. 6 and 7, between 6 and 7, now this 6 and marking here 7, because 7 is not marked here, either 6 or 7, both are absent here, so it is between 5 and 6, between 6 and 7, between 7 and 8. Now 8 is marked here, so this. Now between 8 and 9, 8 is marked here, but 9 is not marked. So this is plate number 8 and let it is 9. Now, dear students, again we have to find out the equivalent capacitance between A and B. Means charge will begin from here, and here it is open circuit, and similarly you can say here it is open circuit, so it's not going to work. So charge will go like this, this and this. So these two are, let it is C and C. It is in series combination, their equivalent will be C by 2. This is C. These 3C are again in series combination, so it is C by 3. So now they are parallel, they are in parallel combination, so equivalent capacitance, simply what you have to do, you just have to add these. Now LCM would be 6, 6C plus 3C, 3 2 are 2C, right? This is 11C by 6. Dear student, what we have done, this is the equivalent capacitance between A and B is going to be 11C by 6. Let's move further to assign that problem. This is point A, 4, this is 9 microfarad, this is 3 microfarad, this is 9 microfarad, and this is again 4 microfarad. This is 8 by 3 microfarad. This is 4 microfarad, and again same condition, 9, 3, 9. This is A, this is B, 4 microfarad, 9 microfarad, 3 microfarad, 9 microfarad. These two are 12 microfarad. Similarly, you can write here, it's a 12 microfarad. And this is 2 microfarad. Similarly, you can make this a 2 microfarad. These two capacitors are 2 microfarad. Dear student, there are some capacitors are given in this circuit, right? I have taken it from some book, I am missing. Might be it would be looking at a circuit, a complex circuit, but it is not so. If you are a smart one, then you can solve just in seconds to such a problem. What we have to do, look here. Above it, the circuit is similar, just below it, right? Or you can say, if you take a perpendicular bisector of this, then whatever is here, similar is here. This is a mirror symmetry problem, you can say, right? So, dear student, let charge Q moves here, then whatever is above it, the same is here, so charge Q will move here. Let it is a Q1. Dear student, look here. If Q2 charge goes to it, it's a mirror symmetry. So this 2 microfarad will receive Q2 charge, right? If Q2 dash charge goes to this 12 microfarad, the same charge will be received by this 12 microfarad. Whatever charge comes here, the same charge will return this through this 2 microfarad, and let Q2 dash charge is received by this 12 microfarad, the same charge will return through this 12 microfarad. Then what I mean to say that this joint has nothing to do with this, right? So what I'm going to do, that this joint is nothing, just a nonsense. So we are just disconnecting this joint and making like this. Now look here, it's the simplest problem. This 12 and 12 are in series, right? So their equivalent will be 12, 12, 6. It will be like this, 6. Now 6 and 3 are parallel. So 6, 3, 9. So here will be really the replacing 2 by 1 equivalent. Equivalent is what? Equivalent capacitance is the capacitor which does same job what all the other capacitors were doing. If you say that 9, 9, 9, these are in series, right? 9, 9, 9, these are in series, then their equivalent, you know, 1 upon C is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. So 1 by 9 plus 1 by 9 plus 1 by 9, 3 by 9, that is 1 by 3. Then you will take reverse. So it is a 3 microfarad. This is the equivalent of these 3 9 microfarad capacitors. Means what all these 3 9 microfarad capacitors were doing here, the same job will be replaced by this 3 microfarad capacitor alone. Now look here, these two, now here is only one capacitor left, that is a 3 microfarad. Dear student, again look here, this 2 and 2 are again in series. So 2, 2 is a 1. So I'm replacing, for me it's very easy, but for you it's not going to be an easy job, because I just remove it simply. At every step you have to make another one new figure, 3, 1. Now look here, 3 and 1. Again charge here is divided, so they are in parallel combination. So 3, 1 becomes 4. This is 4. Now look here, this 4 microfarad, 4 microfarad, 4 microfarad are in series. Whatever charge will pass through, it will pass like this. So 4, 4, 4, they are in series. So their equivalent will be 4 by 3, like this. And similarly you can write below half, here again it is a 4 by 3, right? And now this 8 by 3, 8 by 3 are again in series, and their equivalent will be 4 by 3. Now these 4 by 3, 4 by 3, 4 by 3 are in parallel combination, because when the charge will come, it will be divided into this. So the equivalent will be 4 by 3 plus 4 by 3 plus 4 by 3, means 3 into 4 by 3, 3 would be cancelled. So C is equal to 4 microfarad. This is the way to solve this problem. The problem was not tough at all. It was a mirror symmetry that I have applied, that looking over that how the charge is passing, I just got it that the joint has nothing to do with the circuit. So I just remove the joint and then it becomes very simple for you to solve. Dear student, another problem let's discuss. A problem is like this. This is point A and this is the point B, and let all the capacitors are C. Right? We have to find out the equivalent capacitance between A and B, and the combination is given like this. Right? Dear student, in order to solve such a problem, it's a very simple. Look here. From here to here, there is no any element, either capacitor or resistor. So, if you can take it, if there is no any capacitor, if it is point B, you can write point B here. Or you can say whatever would be potential here, the same potential will be here. Because from here to here, there is no capacitor. And write it, let it is another point D. Now we have to find out the equivalent capacitance between A and B. So I'm going to solve this in this way. Look how. Now, between A and B, there is a capacitor, right? Between, this one is clear now. Between A and D, there is a capacitor. So, let here is a point D. So, between A and D, there is a capacitor. Between D and B, there is a capacitor. Between D and B, there is a capacitor. Between A and B is that much clear. Between A and D that much. Between D and B that much. And between D and B, again this one is also between D and B. So between D and B, another one capacitor. Write this. Now we have to find out the equivalent capacitance of this combination. Like this is C, 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 C. Now these two are parallel, so CC would be, this is 2C, this is C, and now it is C. We have to solve this is C. Now how you can solve? These two are in series, so equivalent of these two would be C into 2C upon C plus 2C, 3C, CC would be cancelled, this is 2 by 3C. Now this and this are parallel, so equivalent will be C plus 2C by 3, that is 3 to 5C by 3. So it becomes, your answer would be 5C by 3. This is going to be your answer, right? What the concept that I have applied this, from here to here it is consisting no element. So if here is a whatever potential would be here, the same potential would be here. So if it is a point B, same I have taken it also as a point B, and so I marked the capacitors, and finally you got the result this. Next problem. Dear student, next problem is a very simple problem. It's a ladder problem. You can say it's a ladder problem. Dear student, this problem has become so common, but because we have to do, you should know the problem about. This is 8, this is 6. Now, sorry, it does not have anyone. 8, 6, like this. This is the combination, right? 8 6 8 6 8 6 8 6. Such a no here this branch is not consisting any capacitor. Now what we have to do? We have to find out the equivalent capacitance between A and B, right? Look here, it is a set 8 6 8 6. This set is repeated infinite times, up to the infinite times. And the combination, such an infinite set of 8 and 6 combination, let equivalent between A and B is C. I have supposed that the equivalent capacitance between A and B is a C, and this is the infinite set 8 6 8 6 8 6, means a ladder of 8 6 combination is repeated infinite times. Let the equivalent capacitance between A and B is a C. If from the infinite set, leaving one, right, this all total combination can be replaced by C, because it was a combination of 8 6 8 6 8 6, and it was repeated up to the infinite times. So leaving one set of 8 and 6 microfarad, again all rest of the combination has again the between A and B, they are the infinite combination of steps of 8 and 6. I have just stopped one, and between these two, there's again, if from the infinite set you decrease one set, then there's no impact on the answer. So what I have done, that this, it was the combination of 8 6 8 6. Ladder was consisting number of infinite steps, and each step was 8 6 8 6 combination. If between A and B there is an infinite sets of 8 and 6 8 microfarad and 6 microfarad combination, then if you stop except of this one, again except of this one combination, their equivalent capacitance between these 2 points again would be the C, right? So here I am writing C. Now look here, these two are in series, so their equivalent will be C dash would be 6 into C upon 6 plus C, and this combination will be in parallel combination with this. So what we have to do, but between A and B equivalent capacitance is C, so C is equal to this, and this combination is parallel. In parallel, what we do, simply we add this, right? Now solve this, you will get a quadratic equation. This is 6 plus C di student, LCM. So 8 multiplied by 6 plus C plus 6C. And now here it would be 6 plus C into C is equal to 8 6 ja 48 plus 8C plus 6C. Or what you are going to get, if you solve C square plus 6C is equal to di, this is a 14C plus 48, or C square minus 8C minus 48 is equal to 0. So C is equal to minus B plus 8 plus minus under root B square minus 4. A is a 1, C is a minus 48, so become plus 48 divided by 2A, and now it will be 8 plus minus 4 8 12, 6 4 10 11 by 2. Now look here, C is equal to 8 plus 11. Square of 10 is 100, square of 11 is a 121. So you might say it's a 10.5 like this thing, right? So it is a suppose it's a 10.5. What I mean to say that it is, this value is bigger than 8. You cannot consider negative here. If it would be negative, then C would be negative, and that is not going to be right answer. So you have to consider only positive value. This would be the answer. You can solve root 112. Root 112. If you want to solve root 112, being a student of physics, you should get the exact value. Root 112 would be, this is 10 plus 112. It would be 10.6. So answer would be C is equal to 8 plus 10.6 by 2, that is 18.6, that is 9.3 microfarad. This would be the answer. Dear student, you might ask that how does I solve this? Root 112, 100 is a perfect square, so I have written here 10 plus 12 was a remainder, so 12 divided by 2 times of it, so it becomes 10.6. It gives you a near approximately accurate value. So C is equal to 9.3 microfarad. Next problem is this problem sometime asked. So each capacitor is C. Each of the capacitor is C, and we have to find out the equivalent capacitance between A and B. Dear student, look here. It is a C. These two are again series combination. These two capacitors in this branch are in series combination, so it is C by 2. This is C by 4. Further, it would be C by 8 like this. And then equivalent capacitance would be what? This is, now these are all the capacitors in their branch are in series combination, and mutually they are in parallel combination. So it would be in parallel combination, simply it is a C. This combination is C by 2, next one is a C by 4, next one is a C by 8 plus C are taken here. 1 plus 1 by 2 plus 1 by 4 dot. You know it's a GP, right? Having the common ratio 1 by 2, right? If you multiply by 1 by 2 in the preceding set, then you will get the next step, right? So it's a summation is a upon 1 minus r. A is a 1 divided by 1 minus r is a 1 by 2. So is a 1 minus 1 by 2 is a 1 by 2. 2 will be the part of numerator. So C into 2, that is 2C. Right? In this way you can solve it very easy. Related to this problem, again I am considering, based on the same concept, I am considering a problem. Look here, this is a point A, this is the point B. It is consisting like this. Look here, this is 1 microfarad, 3 microfarad, 9 microfarad, 27 microfarad, so on. This is 1, 3, 9, 27. Let it is a 4, 5, 6, 7, whatever. Now look here. Dear students, these are again in microfarad, obviously. Now, dear students, again we have to find out the equivalent capacitance between A and B. What I am going to do? Look here, 1 3 1 3 right? Means their ratio is similar. So you can say that these and these 2 points are common potential point, and so there is no charge going to flow in it, so it will not work. Similarly, 3 3 9, 3 3 9, and again it is not going to work. So all this not going to work. So what happens? These are in series, these are series, and equivalent of this one will be, now look here, they are in series, so it is a 1 plus 1 by 3 plus 1 by 9 plus 1 by 27 plus dot dot dot. That is a summation of this would be, again it is a GP having common ratio 1 by 2. So S is equal to A upon 1 minus 1 by R, that is, you know formula, S is equal to A upon 1 minus R, right? A is a 1, 1 minus R is a 1 by 3. So it will become 3 minus 1, 2 by 3, that is 3 by 2. And similarly, it also has the value 3 by 2. And these two combinations are parallel. So equivalent capacitance C is equal to 3 by 2 plus 3 by 2, and equally it would be the 3 microfarad. That is going to be the answer, right? Dear student, in this video, I think it's going to be a very long video. So today I'm giving myself rest, and to you also. I hope that my videos are going to work for you. If you think that my videos are beneficial to your studies, then it's my humble request to you all that please like, share, subscribe my videos, and must put bell icon so that you might be notified about my next video. Thank you.